Okay, let's get started. I like computers. Computers are fast. I like Ruby. Ruby is slow? Well, maybe it's not always the interpreter that's at fault. Maybe it's our code. There's a lot of work happening to make Ruby run all of our code faster, which is very exciting, but this isn't to talk about that. Sometimes we can make things much faster by rewriting our code, or someone else's. I'm Matthew Draper. I'm on the Rails core team, where I normally look a bit more like this, sometimes like this, more often like this. And I work at BuildKite, a CI service that runs your tests in build environments that you can control and scale. So, is our code slow? Let's start with a very simple example, running Rake version. I want to use the right version for my application, so we'll need bundler. Now, none of these numbers are from carefully controlled experiments. I just ran each command a few times on my laptop and picked a representative number. That means they're all using a hot disk and file system cache. Everything would be slower on a first run, but that's harder to measure and hopefully linear, so I'm ignoring it. This ran in 750 milliseconds. We're going to see a lot of process timings like this, and the interesting number is this one on the right. The others describe what sort of work it was doing, but this is the amount of real-world time we had to wait. So bundler's clearly doing some work there. Let's see what happens if we make it easier. By specifying the exact version ourselves, we can skip bundler and go straight to Ruby gems. It's a bit over 300 milliseconds, much faster, but we are doing work instead of the computer. What if we run it without Ruby gems either? Now it's under 200 milliseconds. So while starting Ruby does take some time, Ruby gems and especially bundler are adding quite a lot on top. But we've had to do a lot of work ourselves to see that speed. It works because Rake doesn't have any dependencies, and even then, we need to supply a lot of information in the command line. We want our computers to do that work for us. That's why we like them. But computers are fast, and we can see here that Ruby is pretty fast too. I'm old enough to remember the world before bundler, and I definitely do not want to go back there. But maybe, if Ruby is fast, we can shrink the time bundler takes to choose which version to load without losing the feature. Again though, that's a very simple example, a very simple command. I don't run Rake version very often, maybe you do. It's easy to measure and compare because we know Rake itself isn't doing much work. It's not where our story starts though. Our story starts with me doing a Rails upgrade on an application. An old application, which I was upgrading from Rails 3.2. Anyone who's done that will know it involves running bundle update. A lot. Slowly expanding the list of gems you're updating until you find a set that can move together. Changing version constraints so you don't upgrade one gem too far into the future before the others catch up. You run bundle update a lot. And every time I ran it, it would take a long time. It was taking about 10 minutes. Sometimes that was 10 minutes to produce a log file that I could use, work on top of, run tests, and find the next thing to change. Other times, it was 10 minutes to give me a version conflict error, because I needed to upgrade another gem at the same time. I was spending a lot of time waiting for bundle update. Eventually, I decided I should do something. So I complained about it on Twitter. And that made me feel better for a few minutes. But eventually, I had to work out what was actually going on. Bundler can't be this slow for everyone. Someone would have fixed it. And that turned out to be true. Every time I ran bundle update, bundler was downloading thousands of gemspec files one at a time. That's the sort of thing someone might notice. So what was going on? My first discovery was that it was downloading these same files every time I ran the command. And they were version-specific gem specs, so they couldn't have changed. The easy fix was to open up my local copy of Bundler and hack in a file system cache. It wasn't a proper solution to anything. It wasn't upstreamable. But within 1 or 2 of those 10-minute runs, I had the future runs down to just 2 or 3 minutes. My implementation was just a hack in this case, but adding caching is a very effective way to make something faster. Do the slow thing once, and then remember the result. So I'd made the runs much faster when I remembered to use my modified bundler. But I still had that question. Why had no one else had this problem? It was time to debug why those requests happen. I already knew some background. Bundler used to make these requests, but it was slow. So Ruby Central paid for development of a new, more efficient protocol. And that was a few years ago. I was definitely running a new enough bundler. So why wasn't it using the new protocol? The answer turned out to be a different cache. RubyGems uses a CDN to store copies of common responses close to users. This way, when a user requests a large set of files during a bundle update, most answers come from the local cache, and only a few requests need to be forwarded to the origin server. If no one nearby has requested those files recently, though, all the requests have to be forwarded along. And that's what was happening to me. And I discovered the origin server has a very strict rate limit. So when I ran bundle update, it would request too many files, and eventually one of those responses would contain a rate limit error. Seeing that failure, bundler would switch completely to the old protocol. Anyone using a popular CDN location will only need a few files from the origin, and they'll get to use the new protocol. But if you're on a cold CDN, bundler silently becomes much worse. This is a server configuration issue, but it also seemed like something the client could avoid. I didn't really want to keep patching bundler though. Instead, I wondered what I might learn by doing a scratch rewrite of the behavior. I knew that even with only downloading the files we really had to, there can be a lot of them. An advantage of a scratch rewrite is that you can make architectural choices that make it easier to do what you need to do, because you have a much better idea of what that is. In this case, I built it to handle concurrent downloads from the start. If the slow thing you're doing is waiting on network activity, that's an excellent candidate for concurrency. It's easy to wait on I/O, so just do it 10 times at once. I tried out my implementation, and it seemed to download a full set of files very quickly. If I could write a faster version of the downloading process fairly easily, I started to wonder if maybe there's a bit of a project here. After you've downloaded some gems, the next thing to do is compile and install them. And as I already had the technology to run the downloads in parallel, I could reuse it for compilation. This did need a little more care, because while gems can be downloaded in any order, they can only be compiled once all of their dependencies are available. So I could download and install gems, seemingly maybe faster than RubyGems and Bundler. That's very nice, because those are quite slow operations, especially if you have high network latency. But we don't do those every day. What we do a lot is loading files from our installed gems. It's not 10 minutes slow, so any improvement isn't going to be life-changing. But even a slight improvement could be noticeable. And this is where our Rake version example comes in. 700 milliseconds, 300, 200. Those differences are all in choosing and then loading the right gem and the right files. We can't do this in parallel, but maybe a cache. The slow part here is the file system access, so it's not so easy. Any cache we introduce will still need to be read from disk. But I experimented with storing specialized data structures acting like a database index or a NoSQL store. The standard Ruby behavior involves looping over the load path and then checking each directory for the file that we're seeking. I could make require faster by skipping that load path iteration and just doing a hash lookup. Now, both versions of this code are hugely simplified, but less file system access for each require call means faster loading of files from gems. By pre-constructing the hash of which files are available, the runtime work is reduced. This is similar to one of Bootsnap's optimizations, but it's system-wide and doesn't need any application context. We've added a lot of complexity here to something that used to be very simple, but it does give us a tiny gain in a frequently called code path. Now, this doesn't actually help our 700 milliseconds. That is requiring some files, but as it's bundler specific, it must be mostly the time spent loading the lock file. For that, I did write my own implementation, but while I used general knowledge of which Ruby constructs are faster and slower, I didn't make any special implementation decisions. The lock file is already a cache that can be read with a single file system read, so there isn't a lot to algorithmically improve there. Any speed gain over bundler is probably from missing features. I've aimed as close as possible for a clean room implementation of bundler's behavior to keep me focused on the features that matter to most everyday users. Because of that, I might have just skipped some features that are taking part of that 700 milliseconds. I don't know if that's what's happening, but that's the point. If I haven't noticed it's missing, maybe it's not worth whatever delay it's adding. With gem installation and loading covered, there's a final leg to bundler behavior to look at: dependency resolution. A lot of performance work has been done on bundler's resolver, so I was sure I wouldn't be able to speed it up by just rewriting it. The only hope for a real improvement would be a totally different algorithm, and I'm not that clever. Dependency resolution is a hard problem. It's NP hard. The challenge is to consider all the possible combinations of versions for gems listed in the gem file and their dependencies, and then find a combination that meets all the known constraints, and then find the best one of those combinations, the one that chooses newer versions as much as possible. Luckily, I didn't need to be clever. Around this time last year, Natalie Weizenbaum, who you might know from her work on SAS, published a new dependency resolver for the Dart language that she'd spent quite a lot of time developing, called pubgrub. As well as the implementation inside Dart's package manager, which she had developed it for, she wrote a detailed article describing how it worked. Even more luckily, John Hawthorne had seen that and ported the algorithm as a Ruby gem. I didn't know any of that though, so my experiments sat untouched for some time. They were interesting standalone thoughts, but nothing more. And then John and I met at RubyConf. John mentioned a library he'd been working on earlier in the year, and I nearly dropped my drink. He was talking about the exact piece that I was missing: a new resolver that could use the gem catalogs I was downloading and produce an answer. And it came with two features. It was often faster than bundler's existing resolver at finding a solution. And when it couldn't find one, he told me that it should also give a clearer description of which gems were causing the conflict. I won't try to describe how pubgrub actually works. If the problem space is interesting to you, I highly recommend Natalie's article. The oversimplified description is that it does a backtracking search like most other attempts at dependency resolution, but it does a much better job of learning and propagating dead ends. So it does much less work reconsidering similar options that it knows will eventually fail. So the recommended technique here is meet someone who recently implemented a solution to your exact problem. That may not be quite so easy, but Switching to a better or more specialized algorithm is probably the #1 option for big performance wins. After that lucky meeting, John helped me integrate his pubgrub gem with my earlier experiments. Now that I had implementations for gem installation, dependency resolution, and runtime gem loading, it started to seem like it might be interesting to pull those experiments together and make a thing. The result is Gel. It's a drop-in substitute for bundler and Ruby gems with restricted functionality and can be used locally without any changes to your coworkers or production environments. It's not a replacement though. It supports bundle install, bundle update, bundle lock, and bundle exec. It doesn't support any of the gem authoring tools that come with bundler. It doesn't support local directory vendoring. It doesn't support that other feature you're thinking of. But it doesn't have to support those things because it's not intended as a replacement. It's an alternative that you can use if it meets your needs. Or you always have the option to switch to bundler if you need something more. It's also a very early stage piece of software. The documentation needs work. The UI and error messages need work. And the platform compatibility needs work. So, bundle install, gel install. It currently doesn't support any options. We'll add some in time, but others like bin stubs and deployment mode are probably out of scope. Next, bundle lock, gel lock. This is a less common bundler command. It generates a lock file from your gem file without installing the gems afterwards. Bundle update Rails. Gel update Rails. There's a theme here. The simple commands work the same, just without the options. Finally, bundle exec Rake. This one is a bit different. We have gel exec Rake, but you can also just run Rake and it will do what you mean. Here, if we run Rake outside a project, it uses the latest installed version, 12.3.2. And using gel, we get the same behavior. Inside our project, bundle exec Rake uses the version selected by the lock file. And gel exec Rake does the same thing. But if we just run Rake here in the project, Ruby gems will use the newer one. Gel still knows the lock file, so it respects it. Now the important part. Numbers. We looked at Rake version earlier, so let's start there. Rake version we know is 300 milliseconds. With gel, it's 200. It's just 35 milliseconds slower than when we specified all the paths manually. Switch into a project directory, and again we know bundle exec Rake version is around 700 milliseconds. With gel, it's 330 milliseconds. The same time as a non-bundler invocation through Ruby gems, and about half the time it takes when using bundler to select the right version. But Rake is boring. Rake is easy. We need a more complicated command. We need an overcomplicated command. We need Rails. Bundle exec Rails version, 1.3 seconds. With gel, 500 milliseconds. We can't spend all day asking things for their version though, so let's boot our Rails application. We use Rails runner to boot it, do nothing else, and just return nil. I'll also note that this is without Spring and without bootsnap. We want a direct comparison between the two libraries, so it's simplest to just remove those completely. With bundler, we boot in 9 seconds. This is booting the BuildKite main Rails application, so it's not a 15-minute blog, it's a well-maintained Rails 5.2 application. Gel does it in 5 seconds. That's still not super fast, but we've trimmed a lot of fat. Most of what remains is time spent in Rails itself. Next up is install. From an existing lock file, a fresh bundle install on that same build-kite Rails application is a bit under 6 minutes. It has a lot to do. There's a bit over 200 gems, and Nokogiri and sass-c take just over a minute each to compile. Gel install does more work concurrently and gets the time down to 2.5 minutes. That's over twice as fast, but it's hard to compare. We're talking about writing faster Ruby code, but a lot of that time is spent running C compilers. For a different example, we can consider this single-line gem file. TTY is a module library for writing terminal applications. For us, it's an easy way to install 34 pure Ruby gems. We're again using a pre-calculated lock file, so this is equivalent to running install after an initial clone on a new machine, or perhaps a new Docker image. Bundle install is 4.3 seconds. There are less gems, but still, those C compilers are slow. Maybe they need a JIT. Gel install is 1.3 seconds. Even with a small gem list and no extensions to compile, Gel gets the job done in less time. The last action we'll measure is lock. Taking a gem file and choosing the right set of versions and dependencies that satisfy it and writing out the gemfile.lock without the download and install steps. You probably don't run this much yourself, but here we want to measure it in isolation. We've already seen that the install step is faster on its own. For that same TTY gem file, bundle lock is 1.5 seconds. Gel lock is 1.0. That's the easy file. There are 2 steps to lock resolution, so there are 2 parts that can make it slow. One is having lots of gems from lots of sources. That's what the build-kite app looks like. First, it needs to fetch data from all our sources. The main Ruby gems repository, some smaller pro enterprise type ones, and a few GitHub repositories in the mix as well. After that, it moves on to step 2, considering combinations of gems and versions that might meet our needs. We can't see CPU usage here, but in this case, it's not actually working as hard as it seems. This is slow because it's still downloading more things. Nearly there. So that took 90 seconds. And we can now see that it averaged just 18% CPU. The rest was waiting on network activity. Gel needs to do the same things. First refreshing the sources, and then choosing versions. 4 seconds. Caching makes things faster. Here, the better and pre-warmed cache makes it a lot faster. Without any caches, bundler takes 2 minutes and gel takes 30 seconds. But there is another way lock resolution can get slowed down. Sometimes we can have a very small gem file that is just hard to solve. 2 gems and all the recent versions of one are incompatible with the other. In this example, Quiet Assets is only compatible with Rails 3 and 4. The correct solution is to use the latest available version of Quiet Assets and the last 4.2 release of Active Record. Because we always prefer the newest version possible, to find this solution, all the 5-point-something versions of Active Record and Active Support must be considered first. We won't watch this one run, but despite being a much shorter gem file, this takes 2 minutes with Bundler. We can also see that this time it's all in the CPU. Our improved caching is not going to help here, so it's down to the pubgrub algorithm. Joe does it in 4.5 seconds. So if you'd like to give gel a try, to install, gem install gel. Everyone has Ruby gems, so that's the easiest option for now. Soon I hope to support brew install gel too. To activate it in your shell, you can use shell eval. This just exports some environment variables. This one adds gel's bin stubs to your path, so when you run Rake it will work. And this is the important one. It takes over for Ruby gems, so gel can handle your requires. To fully adopt gel, I recommend adding this to your bash RC. Either way, once it's activated, you're ready to gel install in your project. After that, you can just run Rake or Rails, and they should just work. As for what's next, in the short term, I'm eager to see what projects it does and doesn't work for, and expand that support as people report issues. There are some things I already know need to be fixed. For example, it doesn't know how to compile extension gems from Git sources. Fixing that only requires some programming. I just haven't had time yet. In the long term, I think some of these ideas can be implemented in Bundler and Ruby gems themselves. It's harder because they are mature projects with solidified architectural choices, but it'd be great to make things speedy for everyone. So in conclusion, consider a rewrite. It's well known that rewrites can be a very bad idea, but treat it as a contained experiment that you're willing to throw away. There's a lot to learn. It's freeing to be able to just test your ideas without fitting them into the architecture of an established project. Question tools you use. As developers, we have many awesome tools. Maybe they can still be improved. Don't be afraid to have a go. And finally, try gel. It'll probably break in some way, but report any problems and they'll get fixed. Thank you. Questions, please. Please.
Great job, Matthew. I think you undersold how much faster some of that is. So my question is, if I'm using a Ruby version manager like RBEnv, and I have a similar sort of shell expando thing in my bash RC or whatever, how does gel handle gel's bin stubs? How does it handle me having multiple Ruby versions installed with something like RVM or RBEnv?
If you have gel installed as a gem, then it gets a little more complicated, because when you switch, gel might be gone even though the shell expansion is still there. And that's one of the main reasons that I'm looking to switch to a brew-based installation, so that you can have a single gel version across all of your Rubies. Right now, I think you would need your version manager to cooperate in switching to the appropriate gel shell expansion. Thanks.
I was wondering, sorry, harder than I thought it would be. Can you use gel and bundler kind of at the same time to do different things? So could you use a gel, use gel to make a speedy lock file, for example, which you then install with bundler, or vice versa if you wanted to do it slowly?
Yes. Yes, gel uses the same files as bundler. It writes out the same gemfile.lock that should be bundler compatible. And if it's not, then it's a bug.
Great, thank you.
Yeah, that actually gets to exactly what I was going to ask is gel 100% behavior compatible with bundle, or is there known differences or exceptions to that?
It has limited API, like the internal APIs. If you start talking to the actual bundler or gem constants, it has a few things there to make most projects work. But if you really start exploring, it'll break down pretty quickly.
But for the commands you have, it's supposed to be 100% behavior compatible.
It will be behavior compatible with files, and the commands don't have the same options.
So now Bundler has a plugin system. So is it theoretically possible to use gel as a plugin of Bundler?
I haven't looked at that, and that's definitely a possibility, but I'm not sure how much of the performance you would sacrifice by having to start up Bundler first.
Okay, thank you.
Hi, Matthew, it's a great work, so thanks. So can I use your current Rake file format?
Yeah.
Yes,
Yeah,
thank you.
yes, this reads the same gemfile.lock as bundler 1. And if bundler 2 plus changes the lock file format, then my life gets more difficult. But for now, it works great.
Yeah, thank you.
Thank you. Other questions? Okay. Thank you.